So, yeah, a little bit of time has passed, and well, let's just say that this has been sitting here for a while, and yeah, I have acquired a few things. Unfortunately, the only shop here that sells these kind of stuff, they didn't have too many of all these clamps and alligator clips and test lead hooks and stuff. They only had one black one left. Other colors were sold out, and the black one, it was only they only had one available, so I grabbed it. Some test leads and a couple more test leads. So let's see what we can do with this, and see what we can measure out of all of this. So yeah, we're still at 13 hours, and yeah, we noticed that the cell voltage had fallen. So let's bring in the other multimeter and measure the voltage at the current moment. Voltage at the current moment. Yeah, that sounded correct. So let me bring this in. Yeah, but before we start to use it, let's see if we can somehow create a connector or something that we can use to get this in line with the cell here. So I will start by disconnecting the cell and noting that the positive is on the bottom here. Yeah, should we measure cell or the... yeah, maybe the cell, to see what kind of currents we get into the cell, and then we can check the solar panel as well later. So yes, there we have it. Now what I would like to do then is use one of these connectors. So take a male connector, and fortunately it also has the red wire at the bottom, so there shouldn't be too much confusion, hopefully. And we shall connect it over there. Like that. And yeah, we can of course already measure the open voltage of this when the solar panel is getting some light, maybe. But the idea is to take one of the female connectors and connect to the cell here, and then we can clamp on some alligator clips or something, or a couple of leads here, maybe we can solder some leads. For instance, this one, it's not auto-focusing. Yes, I could maybe, yeah, this one I could safely clip around here, and then can we connect this to, since we have black connector, maybe I can use one of these banana plugs and maybe let's see if it fits. No, this is too large, maybe. Or is it? Oops, shouldn't have done that. Yeah, maybe we need to solder a wire, since this won't work, I suppose, or will it? I'm not sure. I don't think it's getting a connection there, unfortunately. So maybe we have to solder this, a wire to this one. Maybe. Okay. What else do I have here? So this one would fit in there, of course, for instance, but let's, yeah, I mean, what can I do with this one then? Currently not too much, I suppose. Well, I have these alligator clip things. Maybe open these up. See what they can do. So I have 3 wires here, I assume. 1 black. Let's go for the black. So it has a banana plug here as well. This one would go there. And this one then. Yeah, it's possible. Not very safe, maybe. But this one and then one of those. But preferably having maybe a cable. Creating a cable which we could solder onto there and use some heat shrink tubing maybe, and then attach this one and this one or another one of these alligator clip variants to the leads then. Yeah, I suppose that would be good or better. But okay, why don't we just start somewhere? Like, if we just put this cell aside here for a moment, and we can use one red alligator clip lead and one black. So let's see here. I'll put this here, bring this one in, and yeah, the black one of course should be here, and then we shall measure well, first of all, the voltage maybe. So what kind of open circuit voltage will we get? To the battery. once the solar panel gets some light. So yeah, let's set this to volts, and turn this solar panel to the light. Okay, so 2.9 volts currently, but this is not sunlight, of course. But let me use this. Oh yeah, so if I block some of it, we can see that we're in the 500 millivolt, 400 millivolt range, and as I remove my hand, we get up to 2.9. But yeah, let me turn this light on. .9, and if I turn this to maximum light output setting, yeah, 5 volts. Okay, let's see if we can find some sun as well. That would be interesting to see. So hang on a moment. Yeah, almost 6 volts. And now we're back. So as we saw outside, we had an open circuit voltage of almost 6 volts, and yeah, we passed around 6 volts, but it fluctuated a bit. So interesting, yeah, but we can't I mean, obviously this solar cell works, and it does something, but yeah, so I wonder partly what kind of voltage do we get from the solar cell. So maybe I can just like in these conditions here in my man cave, let's see if we can optimize the light here so that we the angle maybe of this, yeah, 3.265. Maybe with a little bit of help from this we can boost that, put it to full output. Yeah, 4.2 or so. But this needs a charge, I believe. So let me see if I can fetch a better lamp. Right, I found one of these AliExpress torches. We can have a look at this one later someday, but it's a rechargeable, very cheap, like a $1 light, but you get an 18650 cell in there with a yet unknown capacity, which will be interesting to find out. And you have one button, and it can produce light, less light with strobing effect, more strobing effect, off, and then if you keep it, you get the SOS. So yeah. Oh yeah, warning, it's too late now, isn't it, for strobing effects, with respect for those with epilepsy. So sorry, maybe I can put that warning into the video later on, since I was a bit late on thinking about that. But the nice thing about this light is that, despite being like a $1 light, it has zoom functionality. So for instance, I can concentrate all the light into one spot, or make the light output wider, so to speak. So if I place the light here on the solar panel, and we can see we get 4.4 volts instead of 3.3, and then I can concentrate the light by zooming into a smaller area. Now we're up to 4.8, 4.9 almost volts, but having a very small light area doesn't really help the voltage here. So as I zoom the light out a bit to cover the area, but not too much more, trying to optimize, yeah, about 4.87 volts. So I can leave this zoom setting, and we can use it later on here. Alright, so what we need to do now is, well, we should make a connector, shouldn't we? So give me a minute, I will remove this from the bench here, and we shall try to create a connector. So yeah, just give me 1 second. Oh, and sorry, a microphone. Yeah, so I have some my USB soldering iron here. These helping hands will be helpful, I hope. But also, actually, I have, since last time we soldered something on this channel, I have acquired another helpful, hopefully, type of thing. Let me just move things about here for a little bit, making some space. So no matter how much I love the scent or smell of solder, it isn't very healthy, let's say. So I did buy something, which I suppose I could have sort of done a DIY thing myself, but I thought that I would like to have a nice device, and it involves some carbon filters, a power plug from which we can now do the peel, It's 12 volt, 1 amp, and it's center positive. So of course you can use perhaps any power plug from some router or something. But let's try this one. I hope it's fine. You never know, of course, with these things. I'm just untangling some leads here. And the main device is over here. I will put the extra carbon filters aside for now. So let's have a quick look at this. It has some rubberized feet here, so we can place it sturdily here. I mean, it's a basic thing, and that's why I liked it, because we have a power button, on off, we have a fan grill, it's made from metal, it's pretty heavy, it won't go anywhere, I hope, and we have what looks to be a standard chassis fan. So I can see DC 12 volts, 0.3 amps. So that should be like, I don't know, 3.6 watts. And it's basically, it is a easily cuttable carbon filter, and I got 2 extras. I remember what this cost, but it had some cost to it. But basically, yeah, you have a fan grill over here as well, and the fan blades are, of course, sucking air from this side and blowing out from this side. And now it's upside down. The feet are here, so yeah, easily serviceable, and it's just a chassis fan with the soldered onto, I suppose, this DC power plug, and so I can change it to an even I don't know, it's this 140 millimeter fan maybe, or 120. Not sure actually. Let's compare it to. I have a Noctua NFP12, which should be a 12 centimeter fan, and yeah, it fits perfectly. So we have a 120 millimeter fan, standard chassis fan it seems, and I get a good casing, easily serviceable. I think everything is screwed in with the screws, and I just place a carbon filter in here, and oh, it has feet on this side and on this side. So let's see how well it works. This wasn't supposed to be a review of this device. I don't know what it cost, but it wasn't overly cheap, but at least it's heavy and sturdy, and so let's try it out. Maybe I shall connect the power plug. It makes noise. Yeah, so it is a high pressure fan, which is I'm happy they went for a high pressure fan, because yeah, we can see the angle of attack maybe here. I can use this lamp. On the blades it's pretty aggressive, which at high speeds should, I suppose, provide some static pressure. But I'm not a fan expert, so. But the idea is to hopefully let this thing draw some of the fumes away from me, basically, when I'm soldering. Yeah, so let's try that. And it will make some noise, of course, but hey, maybe we can live with that. I hope you can hear me during the time we're soldering anyway. Yeah, I need some actual leads. I have to find them somewhere. Yeah, I wasn't too well prepared, was I? I'm taking this pretty much ad hoc as it appears in front of me. Yeah, I will fetch some leads. Right. So I have brought some stuff in. I have a power bank which is charged to connect the soldering iron to. I will place it here. I have a couple of snips, cheap Chinese ones. I have some wire helping hands stuff. I have some black and red wire. I have Knipex wire cutters. I thought, or maybe it isn't. No, it says Wacom tools. Okay, whatever. I have the connector here. Oops. And yeah, I have some solder tin here. Yeah, and then the fume extractor thing. So, well, before we start soldering, let's prepare some things. Yeah, I also have these are the thinnest heat shrink tubes I have, so they should go onto here. But I didn't find the red one. Oh, sorry, I forgot about the lavalier microphone. Maybe it's better now. Hope you heard me, but yeah, the blue will have to act red, and then the black will have to act black. So I did have some other colors of heat shrink tubing, but I seem to have misplaced that box. Yeah, but I have a couple of pieces here, black and blue at least. So we don't need a terribly long lead, I suppose. We only need like a piece like this, maybe, and just to get a connector that we can, with open-ended leads, that we can use the alligator clips to clip onto, maybe, and to get some measurements of voltage and amps. First of all, yeah, let's start with the red wire. We can cut it here maybe, and then we can put this aside, and we'll take the black wire, and maybe we can cut it into a similarly sized piece. like that. And let's gather this and put it aside. And we have to strip a little bit of the wires here. Let's see, this one strips pretty long pieces of wire, as far as I remember, but these are good strips, cable strips. If you want at least, what does it say here, 5 millimeters, I suppose. That's the smallest, and then you can make it longer. But 5 millimeters, yeah, or larger or longer, then it's then they are very good. They don't hurt the wire. Anyway, so we shall twist them a bit, the ends, and prepare them for some solder. So let's do the same thing with the red wire. And twist them. We can put this aside, and I can throw away some stumps of cable insulation, I should say. And the idea is to tin these leads using these helping hands. Maybe we can do it like this and tin them. Yeah, and later on I will use another pair of helping hands, maybe this one, to hold the connector itself. And just as a reminder, so let me zoom in a little bit. This will go in here on this side of things where I have a hole, and in that case we have the red wire, the positive anode, at the bottom. So we can clamp it here and prepare for some tinning. And then yeah, so let's heat up the soldering iron and turn this machine on. Alright, so there will be a bit of noise, I suppose, from the fume extractor. Let's see if I connect it to, what's here, 2.1 amp out, yes, and it's turned on, and we have light. And I will bring in some nice leaded tin, and let's turn on this machine, which will make some noise. Yeah, I can feel it sucking some air through this filter. Oh yeah, look, it actually is sucking the fumes away. That's nice. Okay, let's begin. So, tuning the wire. Over there. And let's do the same thing over here. Okay. Yeah, it is sucking the fumes out, so I can feel a little bit of the nice smell from solder, but alright. And maybe we should tune these contacts as well then. In this case. Made a bit of a mess here with one of the. That's okay. Right, and the let's see here. The bottom one should be red. So let's try to fuse them. I will need a little blob here on my soldering iron tip. For better heat transfer. Yeah. And the black one. Nope. Yeah. Maybe. So yeah, these sit tightly, and now we can thread these heat shrink tubings onto there and hope that they are enough for us to get this done. Let's see here. I will cut them roughly in half, I think. Should be enough. And I will thread them onto the wire like that, and then the blue one will have to act red today. And threading it to it here. Now let me see if this is hot enough to... We can zoom in a little bit and see if we can see the shrinkage. That sounds a bit... Yeah, if you have seen the Seinfeld episode regarding shrinkage, you know what I mean. Should be good enough for our purposes, I think. Great. And while we're at it, so this one is done. But while we're at it, let's put this aside and maybe bring this one in. So I will just turn this iron... Oh. The power banks of today, which turn off after a while, are annoying. This one maybe. Let's see if we can do something with this one. So yeah, the question is... We'll get a wire in here, and we should fasten it here. I shall fetch some more wire. So here I have some wire which is a little bit thicker than we just used on this one, on this connector. So this is... The wire gauge is not the same. This is a little bit thicker, and let's hope that works. So basically trying to do something. Let's cut that off. Maybe we need to let's see if we can push this through here in some way. So let's say we solder it there, and then this wire comes out of there. Will that work? Yeah, it should. Of course I have a red wire. I should have had a black wire for this black one. Maybe. So let's fix that. They didn't have a red one, a red plastic probe itself. It's very annoying when, I mean, they complain that people buy stuff from AliExpress and from other countries, and but then they can't supply stuff themselves. So what am I supposed to do? If I need a thing, I have to take my car or something and go somewhere and I can buy one of these. I'm not impressed. Maybe is a close resemblance of what I feel. So regarding that, so let's cut that. Sometimes it gets stuck in there, then you have to, yeah, and then do the same thing here. And I'm awfully out of focus. Like that. All right. Okay. Maybe I should insert it here first before I do too many other operations. Should be easier from, yeah, I don't need a lot of wire there, but, and I will not pre-tin this right now. Instead I will try to push this in there. Clamp it on. And then we can solder it. Put a bit of a blob over there. Something happened to my helping hands. Something not too helpful. Right, what has happened here then? Let's see. Okay. Alright, well, what's going on? Make sure I put this around. Okay. Great. Sorry, I was out of shot. All right. So let's see if this will work. We have some grooves here that need to fit. Hang on a minute. Am I doing it wrong? Let's see here. All right. I think it works. And we shall verify this by doing continuity check. So let's make some room. Put this into continuity check mode, and yes, 1.6 ohms of resistance, but overall we have continuity, which is what we want. Alright, so now we have this thing as well. Let's zoom out a bit and think about our creations. So, are we good? Let's see here. So, I will put this over here. And let's bring in the device under test. So, to check the cell, where is the cell? Here is the cell. And where is our newly soldered lead? There, with the connector. So, yeah, this one goes here, and then we want to put some clamps onto the wires here to put the ammeter or multimeter in line. So we would like to solder maybe one of these lines together. Yeah. I suppose. Or am I thinking something in the wrong direction? No, I think it should be correct. So, yeah, maybe we can solder the negative wires and put a heat shrink on that. So then we get a connector with one wire detached, and we can but if we want to measure the voltage, then I have no voltage measuring terminal. So maybe I shouldn't heat shrink it or these wires, so I can measure some voltage as well. Yeah, I suppose. So I want to strip this wire a little more. In that case, and I will just wrap it around, wrap the wires around here like that, and we won't put a heat shrink tubing on them, onto them. Instead we'll solder this and then we're good, I suppose. So let me turn the soldering iron on and get the fume extractor running. Get some solder. Okay. Fair enough, I think. These wires are soldered into each other. Great. And basically, yeah, maybe remove a little bit more. It's stuck. There we go. So something like that, and then we don't want these to short, of course. Should have some cable separator maybe. But okay, I think that we have pretty much achieved something. I'm not sure exactly what that is, but so for instance then, do we dare to connect the cell to our newly created lead? Let's hope it works. So I will keep these wires apart. And now that we have that, let's say that we want to measure something, such as the voltage across this cell. In that case, we should put this to volts, and I should be able to attach the alligator clip onto the red, and the black right onto the black. 2.73 volts. So the cell seems to have recovered a bit since it has been lying unused with this device turned off for a while. But 2.73 volts, okay. And if we turn this device on, we don't have a connection there, so I suppose we could connect them like this, and turn it on to continuous mode, and we will see the voltage slowly dropping as the LEDs are lit. Currently we're dropping fairly quickly. But now we want to measure not only the voltage, but we want to measure the current. So let's turn this off. So at 2.7 volts we can see we're recovering a bit already. And in that case, we will simply connect the red wire to the red wire, for instance. Doesn't matter really. And we shall, before we do anything, we should turn this to measuring amps, milliamps, and move the red wire to the 1 amp max value here from milliamp setting. Let's see if I can maybe, yeah, we can put it there, and put this in line. So we have some quiescent current, it seems, but maybe, yeah, and we could actually turn it to microamps first. So let me disconnect this one. We're right at 0, and now I connect this onto there. Yeah, we're drawing 1.5 microamps, it seems, at least. But let's go back to milliamp range and turn this thing on. No? Are we not getting a connection? Yeah, now. So we'll see some fluctuating values now that the light is in flame mode. So let's set it to continuous mode. And yeah, so 2.7 volts at 7.7 milliamps. All right. Let's do the maths. I need to fetch my phone maybe. So and use the calculator here. So 2.7 volts times, what was it, 7.7 milliamps? 7.7 milliamps. So 0.02 watts. Okay, but we don't know the capacity of a cell, but in the listing it said something about 2200 milliamp hour high capacity battery. So 2200 milliamps divided by 7.7 milliamps, sorry, milliamp hours divided by milliamps, 285 hours. But the issue here is that currently the cell voltage is low, so it means that of course the current flow will be low as well. But now to the interesting part. What happens when we get some light onto the solar panel? So we're in the off mode state. And well, 40 milliamps, it seems. Increasing. 80 milliamps. And we have a negative sign here, so current is flowing the other way around. If I turn this, so now it's dark again. If I turn this on to, let's say, constant mode, and then daylight begins, do we get the same sort of output? Yeah, pretty much. So yeah, 80 milliamps. And now I'm interested in the voltage, however. So allow me to bring in my other. Do I have a better multimeter I can use? Or I can. Okay, I can use the amp meter. I can use the clamp meter. It's fine. I hope we'll see the values here. So I shall see what the voltage is like. And let's see here. Yeah, I need. Oh, this is not too easy. 2.7 volts. 2.717. Yeah, so the cell voltage should creep up with time. But considering the fact that we're charging by between 6 and 8 milliamps, it might take a while, of course. Well, 90 milliamps. No, wait. We are in the milliamp range. Sorry. So, yeah, it's not very fast charging. It means we're 0.8 milliamps. No, 0.08 or 5. So, yeah, I thought we were in the amp range, but we certainly are not. Let's use the flashlight. And yeah, now we'll see something happening here. 3 point. Yeah, it fluctuates a bit. But maybe if I do like this. Yeah, 4.2 milliamps. So yeah, 4 milliamps with the flashlight. So depending on how well I manage to direct it. Yeah. And then okay, so this light right now, it does put a 0.1 milliamp into the cell, which is I mean, it's nice for the cell to be charged slowly, of course, but yeah, this at this rate it will of course be a slow process. We almost have to get this out into the wild while there still is some sunlight left. So let's put it outside in the sunlight and see if we can hook this up. So one moment please. Okay, so here's the setup, and now in sunlight, even with the solar panel facing down, we have about 7 milliamps of charge. So no, wait a minute. Yeah, we don't have a negative sign here, so yeah, the LEDs are lit, meaning we're drawing power. Yeah, sorry. So let's face the solar panel towards the sun. Yeah, we'll get a lot more power out of this. So 126.5 milliamps. It's evening sun. Time is almost 6 o'clock in the evening, 6 p.m. So let's see if we can optimize this a bit. Six. Yeah, 130 milliamps. Let's try to turn this way around with the cells going horizontally. Does that make any difference? Not too much. It doesn't seem so. Yeah, so in direct sunlight, about 130 milliamps going into our cell here. Alright, so 130 milliamps, and we had a voltage of about 5 or 6 volts. So if we multiply 0.13 by 5, 65, so 0.65 watts maybe. Is that correct thinking of me? So yeah, but let's do the math then. Go back to the bench. And we're back at the bench. So let's do some bit of math. Let's say that we had 130 milliamps. Let's just assume that it can keep that rate up throughout the day constantly, which probably isn't the case, but let's say we have a really good sunny day and the sun reaches the solar panel, solar cell at a good angle all the time, and so forth, you know. If we have a 2200 milliamp hour cell and we divide that by 130 milliamps, we need about 17 hours to charge it full. And this was direct sunlight, so you would need quite a lot of hours to fully charge a 2200 milliamp hour claimed capacity cell. And well, I think that the direct sunlight conditions that we had now would be pretty much what you could expect, and of course maybe you won't have sunlight even for most of the day, or not all hours of the day. The discharge rate will also vary depending on the cell voltage. So when the cell is fully charged, and the LEDs will be of course brighter because we have a higher voltage from the cell. And I mean, maybe the solar cell can produce more power than, but I mean, what actually enters the cell is what we measured right now, and that was 130 milliamps. And when the cell voltage is higher, then the LEDs will be brighter, and they will also consume more power, which will discharge the cell faster, and then the discharge rate will drop off. But as we saw with the timer, that when it timed the discharge, it took about 11-12 hours to get to 2.5 volts on this. And in such a scenario then, I suppose of course you should get sunlight again, or daylight at least. I mean, during summer then maybe it's dark for 4, 5, 6 hours, and then it will become bright enough to at least not discharge the cell when the LEDs go out, and so maybe you can charge more than you discharge during a 24-hour cycle of the day. So okay, now something awful happened. Yeah, this wire detached itself from our lead here. So okay, I will resolder that. I thought it was sitting there pretty nicely, but maybe I was mistaken. Alright, but I can do that off camera and resolder it, and then we can use it for further explorations. Alright, so what is the next step? Well, I want to charge this cell up and see what kind of capacity it has, assuming this is a LiFePO 4 cell. But since this one didn't have any cutoff beneath 2.5 volts even, maybe it it isn't a LiFePO4 cell. Although it should be, because it's safer, especially if you have it outside, which this device is supposed to be. But to see what happens when this is fully charged at the LiFePO4 3.7 volts and then exposing it to sunlight and see what happens. Will it continue to charge it, or what will happen? And how many milliamp hours will we get into the cell when we reach the 3.7 volts cutoff in a normal charger? So I will have to think about that, how we should do that, and then we can see what kind of numbers we get. But I shall solder this lead back, and hopefully it will stick better this time. But we did get some good readings at least before it loosened up. So right, okay. Yeah, I think that it's time to end this part 2 in the series on this lantern, because the video is just about 1.5 hours long already, and well, we have some soldering and stuff left to do for our continued exploration. Um, but what have we learned in this part 2 then? Well, we learned a couple of things. That the solar cell produces about 5 or 6 volts open circuit voltage, and also that indirect sunlight, in actual direct sunlight, we managed to get a maximum of about 130 milliamps of current measured at the cell. So not what the solar cell itself produces, but what actually reaches the lithium cell in the end. And that's not bad, I think. It's a pretty large solar cell, so it's good. Um, However, we also learn that when using the um, constant on mode, not the flame mode, we were drawing about 7.7 milliamps of current from the cell when we had a voltage of about 3.7 volts. Um, and that's pretty good, actually. It's not too much, so it will last for quite a while. And also, if you use the flame mode, you have an average lower power draw, because not all of the LEDs are lit all the time, and they're not constantly lit, so the average should be a bit lower. And it seemed like we would land on about 5 milliamps instead of 7.7 or 8. So yeah, the flame mode should last you longer, I think. Yeah, but those are our main findings, and we have also created a test lead for the um, JST connector. Um, and now we shall use it a bit more in the next part, so don't miss that as we continue our exploration of this $12 or so AliExpress solar powered lantern. Thank you so much for watching. Have a nice day. Bye bye.